Hello and welcome to the following revision session for A-Level Physics Paper 3. So in today's lesson what we're going to be doing is we're going to be looking at how to answer examination questions for AQA A-Level Physics Paper 3. So if we've been successful and we've learned in this revision session, we should be able to answer A-Level Physics examination style questions, assess our understanding on A-Level Physics and understand what topics we need to improve upon for A-Level Physics. So how should you prepare for this revision session? When completing your work in this revision session, divide your piece of paper into two sections. Make the section on the left hand side larger than the one on the right hand side, and in this left hand side section write down your working out and answers to the questions in the revision session. When you're doing this, make sure to write your answers in full sentences and show your full working out. Then in the right hand side in this section write down any pieces of information which you find useful or any hints and tips on answering questions from this revision session. After the end of the revision session, write up these notes into a revision sheet for you to use independently. So how should you be revising AQA A-Level Physics? So how can you do this? Well, the first step is to learn the key facts, so to learn the knowledge of the course, and you may wish to make mind maps or to write out notes yourself of this. The second step is to test yourself to retrieve this understanding, and you may wish to do this by writing your own cue cards and testing yourself. Then finally, the third step is to practice by practicing answering examination style questions. So you may wish to download your own examination papers to do this. So these three steps of learning the key facts, testing yourself and practicing exam style questions are how you should revise AQA A-Level Physics. So let's now have a look at answering some questions on the practical skills aspect of Physics Paper 3. So figure 1 shows apparatus using an experiment to investigate the energy transfers when a ball bounces on a horizontal surface. The diagram shows the position of the ball when it's first released and the ball at the top of its first bounce. The ball is released from a height x and the height y of the ball's first bounce is recorded. The ball is released 5 times from a height of x of 750 mm plus or minus 2 mm. Height y is recorded each time. In table 1 shows the measurements of y. So calculate the mean value of y for the data in the table. So pause the video now, then unpause the video when you want to go through your answer. Right, it's a very common question to ask you to work out means of repeats given. So to work out your mean, you add up all the values and then divide by the number of values you've added up by. You would obviously exclude any anomalous results, but there aren't any here, so you work it through to be 497. The next question says calculate the absolute uncertainty in y mean, and then the energy lost E by the ball during the collision with the surface is given by E equals mg/hd, where the mass of the ball is m and hd is x minus y mean. So calculate hd and the absolute uncertainty in hd. So pause the video now, then unpause the video when you want to go through your answer. Right, again, it's a very common exam style question to work out the absolute uncertainty of repeated values given. So you should be aware that to work out the absolute uncertainty in a range of repeats is with the calculation the range of the data divided by 2. So you should see the range of the data is the biggest minus the smallest value. Obviously remove any anomalous results from this, so you therefore get the range of 25. So you then divide it by 2 to get 12.5. Now this next point is asking you to work out HD and the absolute uncertainty in HD. Well, what you can do is you can then, from the previous question, you know your absolute uncertainty in Y, and you know the value of y which you've worked out previously, and at that point what you can do is you can work out hd by doing x minus this value. So you know what your value of x is, you know your value of y mean, so you can work out hd by saying the answer is x minus y, so it's 253. Now again, what's the absolute uncertainty in that value? So what you can do is you can work out the biggest value, okay, by adding on your absolute uncertainty in y mean and then working it through like that, and then vice versa for the minimum value. That gets you your range, and then you can work out your absolute uncertainty via that methodology. Now the next question says calculate E for mass equal 2.5 grams, state an appropriate unit for your answer. Then the absolute uncertainty in M is plus or minus 0.1 g. The absolute in the gravitational field strength is negligible, so calculate the percentage uncertainty in E. So pause the video now, then unpause the video when you want to go through your answer. Right, in this first one, we know that the E is energy. So first of all, we want our unit of energy to be in joules. So the unit's going to be in joules. Now we know the equation has been given to us. It's mg/hd, where h is going to be x minus y mean. So the first thing we need to do is just work out all the values through. So we'd work it through to be 6.2 times 10 to the minus 3 joules. So what we do is we times it by the mass, which was given in our previous question, times by gravity, which we know to be 9.81. We multiply it by h, which we worked out previously. Now note for the mass given in the question, that was given in grams, so we've got to convert that into kilograms to get our answer out in joules by doing 2.5 times 10 to the minus 3. Now how do you work out the percentage uncertainty in E? Well, E is equal to mgh. So therefore, what we've got to do is we've got M and we've got H. Now G, it says, is negligible, so we're fine, but because we're multiplying those two values together, we'll be adding their percentage uncertainties. So what we've got to do is we've got to work out the percentage uncertainty of M by doing the absolute over the total times by 100. We then work out the percentage uncertainty in HD by doing the absolute, which you had in the absolute uncertainty, which you had in the previous question, divided by the value times by 100. We then add the two together, and we get 10%. The next question says, Figure 2 shows apparatus used to investigate how the frictional force acting on the block varies with mass m placed on the block. The suspended mass is increased in 50-gram increments. The largest mass that fails to move the block is noted. The smallest mass that does move the block is noted. The value of m is the minimum suspended mass that's needed to move the block and must lie within this 50-gram range. The experiment is repeated for values of mass of m, and the 50-gram range within the m lies within the recorded value of each value of big M. So figure 3 shows the data for small m and big M. The error bars indicate the uncertainty in the value of small m. So draw two straight lines on figure 3 with the maximum and minimum gradients that are consistent with the error bars. So pause the video now, then unpause the video when you want to go through your answer. So again, this question is tested on how your understanding of what error bars are and how they link into gradients. So you need to be drawing two lines. One is the maximum gradient, which is the steepest line possible, and one is the minimum gradient, which is going to be the shallowest line possible. But they've got to go through the error bars. So they've got to go through both the error bars, and you've got your minimum gradient hidden at the bottom of the error bars and your maximum gradient hidden at the top of the error bars, and that should hopefully give you your two lines. Now the next question says determine the gradients of both of your lines. So pause the video now, then unpause the video when you want to go through your answer. Right, so for this one again, you've got your two lines here. So what you should be doing is drawing large gradient triangles and then working out your gradient by doing the change in y over the change in x. Now it's very important to note you've got to draw your large gradient triangles on the graph to indicate where you're taking your values from. Now the next question says the relationship between small m and big M is given by the equation small m is equal to mu big M plus big MB, where MB is the mass of the block and mu is a constant. The pulley is assumed to be frictionless. Determine the maximum and minimum possible values for MB. So pause the video now, then unpause the video when you want to go through your answer. Right, so how would you answer this particular question? So what you're going to have to do is you're going to have to use the graph previously to determine a value for MB. So you use the data given to get values for MB, the mass of the block. And then what you would do is you can then work it through to then determine a value of MB and then use the maximum minimum values from the different gradients to work it through. So again, you can use the value, you can work out MB because MB, you can work it through to be the intercept, because if you work through your equation, you can get MB to equal values in terms of small m and big M. So you can use then that from the gradient to work out the values, and then you can pop them into the equation. Now the next question says, figure 4 shows a transformer in a circuit with an AC power supply. The turns ratio of the transformer is NS over NP. The apparatus was used to investigate the relationship between the turns ratio and the output voltage Vs. The primary current IP and the secondary current IS were also measured. In one experiment, the input voltage Vp was kept constant and a primary coil with 100 turns was used. Table 2 shows the results from the experiment. So determine, using the turns ratio, a reliable estimate for Vp, and then calculate the efficiency of the transformer for a turns ratio of 2. So pause the video now, then unpause the video when you want to go through your answer. Right, it's a very common question in physics paper 3 to be asking to work out values from experimental results given to you. So using the turns ratio, work out what the value for Vp is. So we should know that Vp over Vs is equal to Ns over Np. So we now have Vs and we have Ns and Np. So what we can do is we can work out our values. So what you can do is you can work the transformer equation and you get to about 6.5. So for example, for Ns equals 50 turns, you can say 50 over 100 is going to equal 3.13 over the value of Vp, so you can then work it out for Vp. Now in theory, for the turns ratio to hold, all 3 rows should give you the same value. So as a result, you should do it from all 3 rows and indicate that there should all be the same value in your working out. Now the next question is, you've got to be aware of how you work out the transformer efficiency. So the transformer efficiency is equal to the secondary power divided by the primary power. Now you should be aware that the primary power is equal to Vp times by Ip, and that the secondary power is equal to Vs times by Is. Now it wants it for a turns ratio of 2. So straight away, okay, how can we work it through? Well, straight away we can work out our values from there, and then as a result we can work out our secondary power and our primary power by working values through like so, to then get our answer of 0.94%, which gives 94%. Now the next question says, it suggested that the efficiency of a transformer varies with the input voltage Vp. Describe an experiment to test the relationship between the efficiency of a transformer and Vp. So your answer should include any apparatus needed in addition to the apparatus shown on figure 4, the measurements that you would take, the details of the procedure you would follow, and the details of how you will present and interpret your results. So pause the video now, then unpause the video when you want to go through your answer. Right, it's a very common question on physics paper 3 to ask you to plan an investigation with equipment you've not done an experiment with before, and they tend to sequence the answer with bullet points. Now again, to get your full marks, you should answer each bullet point separately as if it was a separate question, each in different paragraphs. So we'll go through each bullet point at a time. So any apparatus you would need would be a method of varying your primary voltage. You get different values, so you could either use a potential divider, you could use a rheostat, or you can have a variable power supply. And the idea, you'll need a voltmeter or a multimeter to measure that input voltage, because we haven't done that yet, because we only got Vs, we haven't got Vp. Now the methodology is you'd use the same primary coil and secondary coils, okay, and you take a measurements for at least 6 different or 7 different input voltages or input potential differences as such. And then what you would do, as you can be aware, is you can just talk through the investigation about how you'd use your variable resistor to vary the circuit, to then vary the primary voltage, and then you can measure the secondary voltage as so, okay. And then how you process the results is you'd calculate the efficiency for each set of values. How do you do that? You do the secondary power, which is Vs times by Is, divided by the primary power, which is Vp times by Ip, and then finally you're looking to see how the efficiency and Vp link to each other. So therefore you plot efficiency that you just worked out and divide it by Vp. Again, remember just your basic ideas of always repeat the values, okay, always remove anomalous results, make sure you've got a wide range of values, okay, and you know what the measuring devices are as well. The next question says, Boyle's law states that for a fixed mass of gas at constant temperature, PV equals K, where P is the gas pressure, V is the gas volume, and K is a constant. So show that log V equals log K minus log P. So pause the video now and then unpause the video when you want to go through your answer. Again, it's a very common question on physics paper 3 to ask you to manipulate equations, especially ones that involve powers in natural logs. So what we should be aware of is as follows. If we make V the subject, we can say that V is equal to K over P. Now we know that we're going to need natural log in there, so we need to turn that into powers. So we can say that V equals Kp to the minus 1. At this point, when you want to get rid of the powers, you then add in your natural logs, which we know we need from the information given in the question. So we can therefore say natural log V is therefore going to equal natural log K times by natural log P to the minus 1. Now what happens at that point is therefore the minus 1 will cancel through, and therefore it just becomes minus 1 at the front. So therefore it'll become log V equals log K minus log P, and you've proven your answer is so. I mean, another way you could do it is by just saying PV equals K and then take log of both sides. So therefore log PV equals log K. Now again, the rule is, if you remember, that if you are logging two terms that are times together, like log PV, they can separate out but as logs for both sides, and you add them. So log PV equals log P plus log V, and so therefore log P plus log V equals log K, or if you rearrange it, you can say log V equals log K minus log P. The next question says, Figure 3 shows a circuit used to find the resistance per unit length of a copper wire. The copper wire is fixed with tape to measure to a meter ruler that has 2mm graduations. Contact P is placed on the wire close to one end of the ruler and held firmly in place using a bulldog clip. When contact Q is placed on the wire as shown in Figure 3, the voltmeter shows a non-zero reading. Q is moved along the wire until the voltmeter reading is 0. Figure 4 shows enlarged views of the position of P and the new position of Q. Determine in meters the length of X of copper wire between P and Q. So pause the video now, then unpause the video when you want to go through your answer. Right, so how do you answer this particular question? So what you've got to see is determine the length of X of copper wire between P and of Q. So straight away you can measure the value of contact P. Now again, you're going to measure the far right hand side of P, because we're going to take it from the end point of P to the starting point of Q. So you can read it through in your 2mm graduations to work that out. So you can see straight away that if you look on the big graduations, it goes 9, 8, 7, okay, and then it's 2 over there, so that's going to be 6.4. Working it through like that, okay, and then on the other side for Q, you know that it's on 91, 92, 93, 94, and then again is 94.2, so therefore you can work it all through, find the difference between the two, and then you'll see it's 0.879 meters, because we've worked there in centimeters, so we've worked out our difference, okay, which was going to be 87.9 centimeters. You then worked out that the value is therefore 0.879 meters. The next question says, when the voltmeter reading is 0, we know R1 over R2 equals R3 over R4, where R4 is the resistance of the copper wire between P and Q. Determine in ohms per meter the resistance per unit length of the copper wire, where R1 is 2.2 mega ohms, R2 is 3.9 kilo ohms, and R3 is 75 ohms. So determine that resistance per unit length. So pause the video now, then unpause the video when you want to go through your answer. Again, it's a very common exam question in physics paper 3 to determine a value when you're given an unknown equation and you're given values for that. So the first thing you need to be doing is you need to work out what the resistance is going to be. So make R4 the subject, so you can straight away see that R4 from your equation is going to equal R3 times R2 all divided by R1. Then what we do is we then make sure we convert the mega ohms into ohms ohms by times and by 10 to the 6, and the kilo ohms into ohms by times and by 10 to the 3. And at that point we work R4 through to get 0.13 ohms, but the question wants the answer in ohms per meter. Now in the previous question we worked out the distance to be 0.879 meters, so then divide that answer by 0.879 to get our answer out to be 0.15 ohms per meter. Now the next question says the diameter D of the copper wire is approximately 0.4 millimeters. Suggest a suitable measuring instrument to accurately determine D and how to reduce the effect of random errors on the result for D. So pause the video now, then unpause the video when you want to go through your answer. Right, so again, it's really common when you ask what measuring instrument would you use to work out something, and then also how you'd use it accurately. So the first thing to note is we know that the diameter is approximately 0.4 millimeters. So we shouldn't be using a ruler for this because that value is too small to use. So it'd either be using a micrometer screw gauge, or we could be using a digital caliper. Now we wouldn't be using a vernier caliper because it'd be difficult with the actual instrument, so the shape of the object that we're given. Now how can you reduce the random errors? Well, you can reduce the random errors by repeating your investigation. Now again, when you're trying to work out the diameter, there's two ways in which you can repeat it, that you can do it at different points along the wire, and you can do it in different directions because you want to find the average value across the entire wire, and there'll be variations in the wire due to different reasons such as manufacturing errors. And the last thing to note is if you have anomalous results, you would then discard them, and then with your repeats you calculate a mean, and that then reduces your random error. Remember, repeats of measurements reduce random errors. Now the next question says, determine the resistivity rho of the copper with the diameter D of the copper wire to be 0.38 millimeters. So pause the video now, then unpause the video when you want to go through your answer. Now you should see from the equation sheet that resistivity is Ra over L, or resistance per length, which is important because we just worked out previously the resistance per length times by the area. So what we do is we've got the diameter of the copper wire. So what we know is that area is going to be equal to pi r squared because it's going to be the cross-sectional area, which is a circle because it's a wire. So we then halve the diameter to be 0.19 millimeters. We then convert that into meters because we never work in millimeters in physics, to then work out the area by doing pi r squared. We then multiply it by the resistance per length value we worked out previously, and we get our answer out to be about 1.7 times 10 to the minus 8 ohm meters. Always think to yourself in questions, what have we worked out previously? How can I link into the answer? The next question says the copper wire is replaced with constantan wire of diameter 0.38 millimeters. The resistivity of constantan divided by the resistivity of copper equals 30. Suggest one change to the circuit to make the voltmeter read 0 for the same value of X as in question 2.1. Then calculate in millimeters the diameter of a constantan wire that has the same resistance per unit length as the copper wire. So pause the video now, then unpause the video when you want to go through your answer. Right, so how do you answer this first question? So you've got to just think numerically about what's going on. So the idea is we want to make our voltmeter read 0 for the same value of X. So what you could do is look at what you could do for R1, R2 or R3. So the idea is, okay, because the resistivity has increased by a factor of 30, you could decrease R1 by a factor of 30, or you could increase R2 by a factor of 30, or you could increase R3 by a factor of 30. Because think about how changing that resistivity will affect the overall value, and think about how you can link it into the equation shown. Now the next one, the answer is 2.1 millimeters. Now how can you work this through? Well, what you can do is you can say that you know that resistivity is equal to Ra over L. So we know that in terms of resistivity, let's just say it's 30 times greater, so you can pop that in like that. We know the difference is going to be with the same resistance per unit length, so therefore R over L is going to just cancel through. So therefore we know that it's going to be equivalent to D squared fundamentally, because the only factor left that can vary this resistivity up by a factor of 30 is going to be the area, which links into diameter squared. So what we can then do is we can work out the change in diameter, and we get our answer out to be about 2.1. Now the next question says, figure 5 shows two loudspeakers, A and B, that act as a coherent point or sources of sound of a single frequency. C is the midpoint between A and B, and distances OA and OB are equal. QP is perpendicular to CO, and the student uses a sound level meter to measure the intensity of the sound. The meter detects a maximum intensity at O. The student moves the meter along OP, and the intensity decreases and reaches a first minimum at M. The intensity then increases as the meter moves towards P. The student records AB to be 1.80 meters, CO to be 8.00 meters, and OM to be 1.24 meters. So show that the difference between path lengths AM and BM is approximately 0.3 meters. So pause the video now, then unpause the video when you want to go through your answer. It's not uncommon in exam questions for you to be having to work out values based on trigonometries and diagrams given to you and the values stated for you. So you should see from the diagram that you can see that AM is squared is going to be equal, if you can see here, okay, to AO squared plus will be OM squared, like so. So what you can do is you can work it through by saying, well, AM squared is going to be equal to 8 squared, which is going to be AO, which is the same as CO because it's a parallel line acting upwards, and the difference from OM. Now you know the answer is going to be 0.34 because you can see from 1.24 meters and you can see from 0.9 meters what that difference is going to be. So you can see it's going to work through to be 0.34 meters. So you're just looking at the values on the diagram, so you can therefore work out AM to be therefore 0.27 meters. The next question says the speed of sound is 340 meters per second. Determine the frequency of the sound waves. So pause the video now, then unpause the video when you want to go through your answer. Right, so how do you answer this particular question? Well, you should hopefully be aware that the path difference is going to be lambda over 2, okay, because they are coherent points of source of a single frequency, and as you can see that they're coherent, so therefore it's going to be lambda over 2. So what you can do is therefore you can get your answer to the previous question, okay, which is going to be your path difference, and then work it through to be working it out to say that it's going to be 300, work it through to get your answer out to be saying its wavelength is 2 times by the answer previously, and then we can say that 340 over lambda is going to equal your frequency. So therefore, because we know that V equals F lambda, so therefore F is going to be V over lambda, so it's 340 over the wavelength you just calculated to get approximately 570 or 630 hertz. Now the next question says, figure 1 shows apparatus used to determine the acceleration g due to gravity by a freefall method. When the switch is opened, a timer starts and a steel ball is released from rest. The ball falls vertically onto an impact switch and this stops the timer. The timer displays the time t for the ball to fall through the vertical distance s shown in figure 1. A student obtains values of t for different values of s. The student plots the graph of 2s against r squared as shown in figure 2. So the student has used an absolute uncertainty in S to draw the vertical error bars in figure 2. Deduce the student's absolute uncertainty in S and then determine the maximum gradient G max of a straight line that passes through all the error bars and the minimum gradient GM of a straight line that passes through all the error bars. So pause the video now, then unpause the video when you want to go through your answer. Right, so how do you answer this first question? Well, you can work out your absolute uncertainty, okay, by just understanding that the absolute uncertainty is the range of the error bars divided by 2, because it's a visual representation of the range. So therefore you look on your graph and you can see that the difference is 0.08 meters, so divide that by 2, it's 0.04 meters. Now in the next question you should be drawing 2 straight lines in. Now you can see that G max is going to be the steepest line, as you can see here, because it's the maximum gradient, so it's going to give us the maximum value for the gradient, and that G min is going to be the shallowest line possible. Now again, it's really important that when you draw these lines you hit all the error bars and don't miss out the error bars. So you can see that you're clipsing the bottom of the error bars and then the top of the error bars, and they swap over to give you that steepest value and that shallowest value. Then when you've got your lines of best fit in, you can then work out your gradients of each by drawing gradients gradient triangles of each one. The bigger the gradient triangle, the better. Divide y by x and you get out your value. So G max should be about 10.7 and G min should be about 8.7. Now the next question says it can be shown that 2s equals gt squared. So determine a value for g using g max and g min, and then determine your percentage uncertainty in your value for g. So pause the video now, then unpause the video when you want to go through your answer. Right, so how do you answer this first question? Well, you can say that your value for G is going to be the average of G max and G min, because that's the biggest possible and the smallest possible value. So the first thing you note is that G is going to be G max plus G min divided by 2. That gets you your value of G. So at that point you can work it out, and again remember it should be to two significant figures because that's how many values your question was given to. So you should be getting about 9.7. Now your percentage uncertainty is your absolute uncertainty in G. Now your absolute uncertainty in G is going to be the range divided by 2, which is the G max minus the G min divided by 2. That then gives you your absolute uncertainty. So therefore it's going to be the change divided by the value times by 100 to get your percentage uncertainty out, because percentage uncertainty is always the absolute divided by the average value times by 100. Now the next question says, a fault develops in the apparatus. When the switch is open, there's now a 30 millisecond delay before the ball is released. So state the type of error produced by this fault. Then a graph of 2s against t squared is produced when using results from the faulty apparatus. Describe how this graph is different from the graph in figure 2. So pause the video now, then unpause the video when you want to go through your answer. Right, it's very important to know the two types of errors. So an error which is the same for every measurement is called a systematic error, and an error which varies for measurements is called a random error. Because you've got the same error each time, there's 30 milliseconds delay, it must be a systematic error. Now how would this systematic error affect your results? Now what you've always got to remember is that the systematic error will not affect the gradient in most cases, but rather it'll affect the y-intercept or it'll affect the x-intercept, depending on the value that's being measured. Now the value that's being measured is the time, and that's where the systematic error is, so it's going to cause an issue in the value. So what you'll notice is the points will all be displaced further to the right because all the values for t will be bigger than they should be, so it'll affect where your x-intercept is. So therefore as well the y-intercept will also decrease because they've all been shifted across, so it's going to hit the y-intercept at a lower value. But it's important to note that the systematic error will not affect your gradient, so it'll still have the same steepness for your gradient. So that brings an end to this revision session. So if we've been successful in this revision session, we should be able to answer A-level physics examination style questions, assess our understanding on A-level physics, and understand what topics we need to improve upon for AQA A-level physics. So thank you very much for watching this revision session on AQA A-level physics paper 3. Thank you very much and have a lovely day.